So I feel like this is the point of the Monty Python episode when you call for something completely different. What I'm going to be talking about is a public, kind of personal approach to visualization and public outreach. And I'm hoping you'll just indulge me for the first part of this, which is a little bit of a kind of philosophy of how to approach visualization, a word that everyone likes to use because it sounds cool, but has a lot of different meanings depending on whom you're speaking to. And I'll confess up front, too, that this is a presentation that I've tweaked over time. The inspiration for it was actually my previous job. When I worked at the American Museum of Natural History in New York, I had gone through a process to apply for the job that I didn't even find out the title of until very near the end of the process. And it turned out that my title was Science Visualizer, which, again, sounds really cool. But I kind of wondered, what exactly am I supposed to be doing? I envisioned sitting in my office with tapestries and incense burning and sort of visualizing science. And because I wanted to make that joke in a presentation, I did what anyone would do and did a Google image search, and I came up with this image of Ganesh, superimposed, as you can probably tell, on an image of the Pleiades. Now, I suddenly realized, actually, there's something meaningful here. Because the same way that I look at this image, and with the limited knowledge I have of the culture involved, I can kind of say, well, I know that the presence sitting at Ganesh's feet and the position of his hands, they have meaning, so I don't know what they are. But I realize that that kind of encoding of visuals is something that we do in science all the time, and is something that actually often prevents comprehension of visuals by our audiences. So visualization fundamentally is taking data, all of the ones and zeros that we either collect or calculate, and turning them into images. Now those can come from observations of the sky or of whatever phenomenon you want. Of course, there have been articles written by horrified journalists who realize that in fact the universe doesn't look exactly like Hubble images do, that in fact you have to make subjective decisions. And if you talk to Jeff Hester about this image of the famous pillars of creation, he chose the colors very carefully in order to highlight the information that he wanted to see. Now, as it turns out, if you're an art history major, you might look at this and say, oh, this actually employs the ideas in color perspective, so that warm colors like the structures of the nebula come forward. Cool colors like the blue of the oxygen emission recede to the background, and you have this wonderful dimensionality, which wasn't really Jeff's intention at all when he created the image, although it's not unrelated to the choices that he made in the color spectrum, the color choice for how he assigned the visuals. But at any rate, we can use data to drive a simple representation of an image. We can also, of course, combine observed data with a computational model. So this is an oblique view of the three-dimensional model of the Orion Nebula created using Odell's calculated surface for the ionization region in Orion. This was done at the American Museum of Natural History for their opening show in the year 2000, Passport to the Universe. And then, of course, we can just calculate stuff out of whole cloth. This doesn't show up too well, but this is, again, another AMNH nebula. We nicknamed it the Hayden Nebula for the Hayden Planetarium because it was actually, in collaboration with Tom Abel, we were attempting to show the formation of an ionization region around a new star. But, of course, visualization also encompasses some of the more mundane representation of data that we use. So these are some of the more public-facing images, but of course, we also represent data in the simple, I mean, this is of course so deeply embedded in the minds of any student of astronomy that the Hertzsprung-Russell diagram actually is just imbued with layers of meaning. Now, it only takes a moment for anyone in this room to kind of look at this and say exactly what it is. It happens to be I think, 100,000 brightest stars in the Hipparchus catalog. But we can even immediately surmise what the color represents even without much of a representation, although it is barely indicated here on the image, that is representing number density as the points pile on top of one another. We simply color code them differently. However, as I said, I've given this presentation to a wide variety of audiences, and let me assure you that people without an astronomy background do not reach the same conclusion. So we start to embed these layers that are so familiar to us, and when we present them to members of the public, we often have challenges. Now, just very briefly, we also have more schematic representations of things like the Hertzsprung-Russell diagram. And again, this has many layers that are very familiar to those of us who have studied astronomy, but then we can also draw sort of cartoons, and this is where we get into a more familiar kind of structure for many people, because there is a kind of common language of the comic strip of sequential art. And so all of these different things that we can refer to as variously visualization, or what I would call kind of infographics once we get to this realm, are fundamentally about communication. And so I like to just propose this very simple structure when we talk about visualization. There's communication to oneself, which is effectively data analysis. It's where you're taking the numbers, turning them into an image in order to help you understand what's going on with the data. Now, have at it. Any techniques, any style that you want to use to help you understand that image, that data, those data, is probably worthwhile. But then, of course, when you want to present it to someone else, you have communication to your peers, which is where we get into sort of the Hertzsprung-Russell diagram territory, where we can communicate with familiar representations of data. But I would note that actually many members of the public are not even all that comfortable with the abscissa and the ordinate. I mean, that's not something that, in fact, all of our audiences immediately grasp. You tend to need to take time to actually explain what's going on when you show even a simple two-dimensional graph. And then, of course, there's communication to a general audience or general audiences. And that's really, obviously, kind of the focus of what I'd like to just talk about using as a specific example planetariums and my own institution. But I just, again, want to note that I think many of the challenges that we experience and miscomprehensions that occur with members of the public looking at information presented to them visually is kind of an error that occurs between that second flavor of communication and the third, that we tend to instinctively go back to representations that may not have the same meaning to broader audiences. And then finally, I just feel compelled to note, kind of like I referenced when talking about the Pillars of Creation image that Jeff Hester deliberately colorized in a specific way, as with all means of communication, all visuals incorporate an element of subjectivity. There's no such thing as an objective image. Again, even choosing the abscissa and the ordinate, even choosing log, which is linear scales, all of those subjective, and actually in discussing the CMB and the BICEP2 results, you could even see that. You change the scale a little bit on some of those graphs and your data start to look better. So I think that that's an important thing to note. So again, what we're really talking about is taking the ones and zeros of data to create images that are intended for a public-facing audience, but we have to be wary because this embedded visual language, the familiar visual language that we use, can often, in the same way that we look at an image of Ganesh and say, New Agey Hinduism, people might look at something like this and just say, science-y, and not actually be able to or be interested in exploring further. And at this point, actually, I'd like to mention a great reference, and this is actually, I think, highly applicable not just to public-facing visualization of data and representation of data, but also as we talk about how to represent data for peers, even to some sense for ourselves. This is a table that comes from Noah Linsky's Complex Diagrams blog. It's also in his book, which I'll mention in a moment. But we actually know how the visual perceptual system works. We actually know that. We know a lot about it. And I think that's a whole lengthy discussion we could have. But what's great about this, if you're talking about a two-dimensional chart or representation of data, NOAA has compiled a great cheat sheet because what you can see is that there are certain things like the placement of a point in two-dimensional space, the size of an object, the intensity, brightness of an object. These are things that our visual system inherently recognizes. And orders, so that there's small to large, there's bright to dim, or bright to dark. But there are other things that the visual system does not logically recognize. For example, that all too familiar rainbow spectrum. Notice that our dark blue to red goes through several kind of brightness shifts. So you have an intensity difference. Yellow and even this sort of cyan show up more, are more perceived as brighter by our visual system. And so when you look at this, for example, in black and white, it's, you're seeing something different from what the intensity, you're seeing something different from what is intended. And the danger with the rainbow color scheme is that because the sort of Roy G. Biv ordering of color and concept of wavelength is so deeply embedded for many of us, we don't recognize that that is not a natural ordering for people who are looking at our visuals. Pardon? Well, natural ordering actually, like if you wanted to show, I mean, you could actually think about this in this grayscale. So just going from dark to bright would be a natural ordering. And if you wanted to add a color component, you should just recognize that darker color is, and maintain continuity from dark to light colors. Another idea would be to, what I tend to think about a lot is when you transition from warm to cool colors, so from reds and yellows and oranges to greens and blues, that transition point should have meaning because your visual system actually perceives a stronger difference there than you might think. I will say that actually it's a good setup for the next slide because Noah Alinsky's book, Data Visualizations, there's a lot of literature out and about for talking about how to represent data in naturally and easily interpretable ways. What's great about this book is it's not my favorite book, but it is the shortest book. It's a very tiny, thin volume. Noah did a great workshop actually at AAS a couple years ago, and this is, you can almost just read this in one sitting and get some really great ideas about how to represent data. Again, not just for the public, but actually for publication and other applications. And I also would say, don't bother with the print version. It's print on demand. For some reason, they inexplicably print it in black and white, even though it has color illustrations. So just, it's available from O'Reilly, obviously, so I'm just going ahead and invest in the PDF. And Noah actually talks about things like Anscombe's quartet, where so the need for visualization sometimes to show you, these data points would all have similar statistics, but in fact show very different physical manifestations in terms of interpretation. And another thing I'll just quickly mention is what I think Noah talks about and where his ideas kind of overlap with mine is he thinks of the kind of reader or the audience as one component of this triangle and then describes, on the one hand, the designer who is trying to represent or interact with the data and creating visuals that are somewhere in this kind of residing within this triangle. So if you look at any particular visualization, you can tend to place it somewhere within this triangle. And it's kind of a useful way of thinking about what you're trying to do. At any rate, I actually wanted to then just talk about the specific kind of public-facing content that we do at my home institution, the California Academy of Sciences in San Francisco. So this is our new building, which was opened in 2008, but we're actually a 160-year-old institution that is engaged in research in the life sciences. And although we have a network of fellows, it includes people such as Joel, who are astrophysicists and astrobiologists, we don't do that kind of work in-house. However, we are a research institution. And that's part of what motivates us to, as often as possible, represent, whether it's in the planetarium or on the exhibit floor, represent authentic data, because we see that as an extension of the authenticity that any natural history museum offers. So we have an annual attendance of about 1.3 million, about 600,000 people a year come to Morrison Planetarium. So what I'd like to just briefly touch on is a little bit of the specifics of our institution and how we use visualization and try to deploy it, but also I'd like to just kind of hint at a sales pitch for planetariums in general. There are thousands of planetariums in the US, and hundreds of them have the kind of digital technologies that can display astronomical data in a way that's sort of well-equipped for talking about 21st century science. And Morrison is one example, but in fact, I think there are many opportunities for the astronomy community in particular to engage with planetariums. It's like having a branch office in every city of the nation, because almost every major city has a planetarium, and most of those now really actually have this access to this kind of technology. So the bulk of our visitors see shows that are pre-recorded and often incorporate visualizations. For example, Dark Universe, which was a co-production between the California Academy of Sciences and the American Museum of Natural History. The visualization that forms the background is actually from Ralph and Tom's group. And in fact, they did about a third of the show is your, or maybe a quarter? Oh, okay. So 20% of the show is really, includes visualizations from HiPACC. And these, I think what's critical to note is that these visualizations then play a role in telling a story. And knitting these visualizations into the storytelling is the challenge that we really engage with. At the California Academy of Sciences, we produce our own programs as well. And so another data set from Ralph and Tom from our show Life, a Cosmic Story, which is really telling the story of life. And so the first stars visualization here is a component of this larger narrative. I was going to talk a little bit about color choice and such there, but we chose kind of the pink color to represent the sort of pinkish glow of an H2 region, and then the dark matter is shown in a more neutral kind of bluish gray. We also have created shows using other simulation data, in this case from Lawrence Livermore National Labs, of seismic event. It's maybe a little hard to read here, but this is the San Francisco Peninsula, and this is in yellow, a highlighted Hayward Fault, not far from where you're sitting right now. And we simulate, this is actually the collection of fault plains under the Bay Area. And we simulate a magnitude 6 earthquake on the Hayward Fault. Again, that's integrated into a story in the sort of pre-recorded visuals that we give to our audiences. We also use real-time data. And this is just, as you can clearly see, ripped off of Google Earth, but this is a data set that we've incorporated into real-time software in our planetarium, because the planetarium isn't just a playback machine, it's not just a DVR, it also has real-time capabilities, so it's also a PS3 or PS4 or Xbox. So we can actually integrate real-time data into a three-dimensional model and navigate audiences through this. This happens to show Earth-based data, and what we're actually looking at is the projected range of a species of California oak, the valley oak, in the year 2050. So we, in the show that was part of the NOAA-funded grant, we actually talk about the changing distribution of plant life in California. So at the Academy, again, because we're a life sciences institution, we do shift focus from astronomy. But I think one common theme, and actually Joel and I were talking about this over at lunch, so this is where I get up on my soapbox to say that there's a very important conceptual shift that the general public is completely unaware of, and that's the whole idea of computational science and the contributions of computational science. They hear about it in terms of scary things like climate change or earthquakes, but I think there's a tremendous opportunity in talking about astrophysical simulations to open people's minds to a better understanding of what this new way of doing science looks like. And I think it's absolutely critical for many reasons for people to understand this. So my hope is that, and evidently Joel is writing a book, so he may be on the leading edge of this, that we can actually communicate this to our broader audiences, the importance and relevance of computational science. So in closing, I'll just kind of go over the different approaches we take to integrating visualization, not just in Morrison Planetarium in our kind of larger theater, but we actually also have in the queuing area to the planetarium about a 6K by 1.5K display where we can do real-time visualization as well. And this is always mediated by one of our presenters, one of our educators. And so this is a way for us to actually be able to, even if a visualization is sort of encoded in the visual language that is more familiar to peer-to-peer communication, we have presenters who are able to work with audiences and kind of describe this. This then becomes sort of a proving ground for integrating visualizations into our other programs. We have a stereoscopic theater as well. It's currently closed, but we have real-time capabilities in that space as well. And I'm a collaborator on a grant looking at how people learn and how storytelling best works with using stereoscopic imaging. We also have this little space on the floor that accommodates about 15 to 20 people for presentations. The 4 screens that are in a checkerboard pattern there can be moved together to create a single screen to do presentations. And again, we can use these same kind of 3D software to talk about visualization on the public floor. And we even have a little portable dome that gets carted out to different areas to be able to do some of the same things that we do in Morrison Planetarium on a smaller scale for smaller audiences. And unfortunately, I only have a picture of one presenter in the planetarium, but almost all of these programs are driven in large part by presenters. And I do think that going back to the idea that planetariums are an interesting resource for the astronomy community, there are many very skilled interpreters of astronomical science who are interested and willing to proselytize on the part of the research that's going on. And there's an increasingly large community that's going to be very engaged with trying to understand how to interpret data for the public. So I would just offer that up as an opportunity for the astronomy community to really integrate with the planetarium community and be able to connect with audiences that might not otherwise see your work. Of course, Neil's got the millions of viewers with Cosmos, but the intimacy of the personal connection for someone visiting a planetarium or institution like the Academy, I think is hard to beat. So thank you very much for your attention. Unfortunately, I can't stick around too long after this talk, but I will note that the first part of my talk, when I was describing the kind of approach to visualization, I actually just tweeted the link to an article, so if you look at my Twitter account, you can actually read in greater detail some of the ideas I was proposing about an approach to visualization. So thanks for your attention. So actually, the great thing about our current presenter team is that we have a wonderful combination of people with acting backgrounds, writing backgrounds, science backgrounds, and a couple of them are even grad students in astronomy at San Francisco State. So it becomes kind of a group exercise. And in fact, we do things like conference calls with Joel, because Joel was just on the phone with our team on Monday talking about, actually we originally scheduled the call to talk about the recent Fermi results. But since we're running Dark Universe in the planetarium, we actually have incorporated a live presentation component into every showing of that show where we talk about the recent results from the search for dark matter. So we actually had already scheduled the call with Joel to talk about the Fermi results, and we ended up talking a lot about BICEP too as well. But it is a constant effort, and it requires an investment of resources. But when you look at the amount of money we invest in technology, the investment in people is, I think, relatively minimal.